Starting on page 87, our notes on triangles. Our I can statements tell us that by the end of our lesson, we should be able to construct triangles from three measures of angles or sides. And the reverse of that also is identifying whether or not you can make triangles with certain angles or sides. Second, to determine when the conditions create a unique triangle, meaning only one, more than one triangle, or no triangle at all. We started off with some simple notes reviewing our information, what we know about triangles, in that they are polygons with three sides and three angles. And we talked about the different types of angles that are found in each of the different kinds. They are labeled according to their side, to their angles. Here in our first one, we have an acute triangle. It has three acute angles. Our second one, the right triangle, we know it is a right triangle because of the little square there in the corner. And notice that this right angle, you also have two acute angles there as well. And then our third one has one obtuse angle, meaning one angle greater than 90 degrees. And our other two angles are also acute because you will always have at least two acute angles in any triangle. So one way to identify is according to their angles. Our second is you can identify or classify according to the sides, and that depends on whether or not any of the sides are equal. In an equilateral triangle, all three sides are equal, and so that is denoted here with the little line or slash on each of those. Our second triangle is called an isosceles because it has two sides that are equal. And then our third one, our scalene, has no equal sides. And our final item we need to remember about our triangles is that the sum of the angles, that means if you add up all of your angles in your triangle, they should always equal 180 degrees. We also had our exercises that we worked along with Rob from our Math Antics video, where he went over each of these items again. And then we did an investigation here on page 89. Your investigation where we took our strips of paper of different lengths and determined whether or not those would create a triangle. And one of the things that we noticed is that when the two short sides of the triangle, sometimes they were not long enough to meet. And so this helped us to understand our triangle inequality theorem. This tells us also on page 89, the other side of that sheet, that in order for the three side lengths to form a triangle, the sum of the two shorter side lengths must be greater than the length of the longest side. And we write that here as our A plus B, our two short sides, must be greater than the length of side C. All right. Our example here, they ask, will the lengths of 12 centimeters, 7 centimeters, and 5 centimeters form a triangle? First step is to identify our shorter sides. That would be 7 and 5. Second, we identify our longest side. That is our 12. That's going to be our C. And then we plug these into our formula that we have here at the top. So our two short sides, 7 plus 5, must be greater than our longest side of 12. When we combine these terms, 7 plus 5 is equal to 12, and 12 is not greater than 12. So no, these will not form a triangle because the two shorter sides just won't meet. Below this, we had some practice problems where we looked at whether they gave us the different lengths and you had to decide if that would make a triangle. Sometimes they give us different sets of lengths and you have to determine which will or will not form a triangle. And please pay attention to your question, because if they're asking you for a knot, you're looking for the opposite of what you would be thinking otherwise. And here 4, 5, and 6, again, practice problems there, looking to see which of these side lengths or what could be your third side length.